Now we can also consider a translation parallel to the x-axis. This would look like this. So it would move in a horizontal, the graph would move in a horizontal manner, and that is parallel to the x-axis. Now if we look at what happens when we do this, if I move it in that direction, which is in the positive direction, this is a translation of factor 3 parallel to the x-axis. We can see, if we just look at the points where the curve crosses the coordinate axes, or the x-axis, and we can see the point 2, 0 has moved to the point 5, 0. So that has moved 3, the point 4, 0 has moved to the point 7, 0, that's also moved 3, and the whole graph has moved 3 horizontally. If we look at the equation here, the equation of the new graph is y is f of x minus 3. So by moving in the positive x direction, we have to subtract 3 from the value of x. This makes sense if you look at the equation here. If x is 5 in f of y equals f of x minus 3, if x is 5, we have f of 5 minus 3, or f of 2. Well, we know the value of f of 2 on the original graph. F of 2 is 0 because it crosses the x-axis there. So in the new graph, when x is 5, f of 5 minus 3 is f of 2, and f of 2 is 0. So it crosses the x-axis when x is 5 in the new graph, the translated graph. To translate in the other direction, the negative direction, over here, this is a translation of factor minus 7, and that is achieved by adding 7 to the value of x. We can see that 2 has moved to minus 5 in the negative x direction, so a translation of factor minus 7. So a transformation of f of x plus 7 here is a translation of factor minus 7 parallel to the x-axis. Alternatively, a transformation of f of x minus 7, that is a translation of factor plus 7 parallel to the x-axis. It's the translation. The factor is has the opposite sign to the actual factor.